will probably be close to the last things we're going to be covering, because we're going to cover the derivatives and the integrals of the inverse trig functions. So today what we're going to do is we're just going to talk about the inverse trig functions and just review them from pre-calc. And so first of all, when you see arc sine of x, you might remember that as inverse sine of x, written this way. Okay, same thing with inverse cosine, inverse tangent. The arc cotangent, arc secant, and arc cosecant you haven't seen because we didn't look at those. But basically, those are just the inverses of all of those individual functions. Is that something you necessarily need to write down? Probably not. Basically, the biggest thing you need to know is that arc sine, the domain was -1 to 1. The range is -π12 to π12. Okay, with arc cosine, domain -1 to 1, range is from 0 to pi. And then arc tangent, domain -infinity to +infinity, range is -π/2 to π/2. And if you forget, this is a table taken from your book, and you can always get that there. Okay? So let's go ahead and look at an example. It says to evaluate each function. This is where your chart came in handy. I think it was your blue chart came in handy last year. Pink. Pink, sorry. And so there are two ways to actually do this. Okay, we're going to review the long way. Now, arc sine, if you remember, was from -π/2 to +π/2, which basically means it is in quadrants 1 and 4. Okay, so do we understand where the 1 and 4 come from?
What was it? What were the coordinates of it?
It was from, if you remember, from the very first slide, and maybe we should go back and put quadrants. Arc sine is -π/2 to +π/2, which is quads 1 and 4. Okay? 0 to pi is quadrants what? 1 and what? 2. And then tangent is the same thing, quadrants 1 and 4. So that should kind of help. And the other ones all fit into play too. Cotangent would be, arc cotangent would be quadrants 1 and 2. Arc secant quadrants 1 and 2. And arc cosecant will be quadrants 1 and 4. So now of these two remaining quadrants, I need to draw a triangle in one of those. And that triangle has to have a value or have a sine value of -1/2. So of those two quadrants, where is sine negative? 1 or 4? 4, because remember in quadrant 1 everything's positive, everything's hunky-dory. So what I'm going to do now is I'm going to draw a triangle in, and I'm going to draw a sine of -1/2. Sine is opposite over hypotenuse. So here's my angle right here, and we'll call it x. So sine opposite over hypotenuse, which you could put the negative in if you wanted, it doesn't matter. And so this is a special type of triangle. Does anybody remember what type of triangle it is?
Right.
It's a right triangle, and it's also a 30, 60, 90 triangle. How do I know it's 30, 60, 90? Because you've got a 1 and a 2. The relationship between those is that the smallest side is always half the hypotenuse. And so this would actually be root 3. So now we need to find the angle. So the angle here would be what I measure from 0 down to the terminal side. So there it's actually -30 degrees, but you know I won't let you answer in degrees. So do you remember what that is in terms of pi?
Pi over 4.
Close. Bigger.
Pi over 6.
Pi over 6. Okay. Okay, we're going to do more of them, trust me. So let's go and look at this one, arc cosine of 0. That's in quadrants 1 and 2. So you can go ahead and eliminate 3 and 4 right away. Now this is the thing. How do you draw a triangle with a side that's 0? And so we need to think whenever, and this is kind of one of those things to file away, if you're dealing with sine and cosine, if you ever get 0 or 1, that means that it's going to be located on one of the axes. And we got to find where. So if you remember all of these coordinates, this one is 1, 0. This one is 0, 1. This one is negative 1, 0. Now, do we remember cosine and sine? Cosine goes with what coordinate? X. The reason why it goes with X, this is the way to remember, it's alphabetical. Okay, cosine and sine alphabetically, see how they're written? X and Y alphabetically, they match up. So of those 3 points, where is X 0? Yeah, at this one, which is a measure of 90 degrees. So my answer is 90 degrees, but you know I won't take that because it needs to be in radian form. Pi over what? 2. 2.
So all you do is in the 90.
On that one it will be. Let's look at this one. Arctan of root 3.
1 and 4.
So arctangent 1 and 4 automatically you know. Of those 2 remaining ones, where is tangent positive? Top one.
I didn't know that.
Because the top one, quadrant 1, everything is positive in quadrant 1. Okay, so that's the way to remember it. 1, everything's positive. 2 and 4, you're going to have your negatives.
So that's not special for any of the terms?
Nope.
It's always
Quadrant 1 is positive for everything. So now I need to draw a triangle where tangent is root 3. I don't have a fraction here, so I'm going to make it a fraction by putting it over 1. So here's my angle. Tangent is opposite over adjacent. Okay? And so hypotenuse here would have to be 2. So this is a 30, 60, 90 triangle. Remember, in a 30, 60, 90 triangle, the 30-degree side is always opposite the 1 or the 1/2. So the root 6 is actually 60, or root 3 is actually opposite 60 degrees. So my angle will be measured from the terminal side up. So it's 60 degrees, which is equivalent to pi over 3. Okay. All right, let's look at this one. This one's a little different because it deals with a decimal.
Is it 1 and 2? You just make it 1 or 1.
That's what we're going to talk about. So it's quadrant 1 and 4. Of those 2, where's my triangle going to be located? Top. Okay, so now the question is, well, how do you do that with the point 3? I can write point 3 as 3 over 10. So sine is going to be 3 over 10. Now this one isn't a special triangle. So since this isn't a special triangle, let's go ahead and evaluate that. And so and the other thing is you need to make sure that you are in radian mode, guys. Radian mode. So go up to mode and make sure you're in radian mode. Inverse sine of 0.3 is what? What'd you get?
0.30469265.
So 0.3047
Yep.
to 4 decimals.
Oh, yeah, it's finding the other side too. Yeah.
This thing, we already know it's not a special triangle, so we can go
So
with
you
that.
have to. So what do we, how did you find that then?
The inverse sine, so on your calculator, do the inverse sine of 0.3.
Got it.
All right, we're going to look at one more real quick. I think. Let me double check. Actually, I think probably two more. Arctan of 2x minus 3 equals pi over 4. Now this is an equation. Now we need to think back to arctangent. That's inverse tangent. We need to solve for x, so we need to get rid of that. What undoes arctangent?
Tangent.
Tangent. So I'm going to take tangent of both sides. On the left side, what ends up happening is your tangent and arctangent cancel. And what will that leave you with? 2x minus 3. On the right side, I need to evaluate what is tangent of pi over 4. Tangent of pi over 4 is 1. So now all I need to do is solve that equation for x, and I'm done. So you should get 2x to equal 4. X equals
That's fun.
2.
That's all you do.
That's all you do.
You said it was impossible for you.
Okay. This is going to be our very last one for today. Tomorrow we'll do derivatives. Given y equals arc sine of x, where y is between 0 and pi over 2, find cosine of y.
So do you just go on the
So what
first
quadrant? Yep, we're just in the first quadrant because it says from 0 to pi over 2. Okay, so we know we've got a triangle in that first quadrant. And I need to find the cosine of y. So first of all, arc sine of x. I can write that as a fraction, x over 1. Right? So this is like the arc sine when you had the 1/2 or the arc sine of 1. And so in this triangle, x is the opposite side, 1 is your hypotenuse. Now I've got to find this missing third side. So to find this missing third side, I've got x squared plus, let's call this b squared, since that's Pythagorean theorem, equals 1 squared. So let's go ahead and solve for b. So basically I get b squared to equal 1 minus x squared. You see where that comes from? So then what does b equal? Square root of 1 minus x squared. Now normally when we take the square root, we take both a positive and a negative. In this case it's got to be positive because of where it's located, because it's a positive x. So square root of 1 minus x squared. So let's go back. We've drawn our triangle. Let's look at the original problem. Original problem says find cosine of y. So in this triangle, cosine would be root 1 minus x squared over 1, which is just 1 minus x squared, the square root of that. And that's it. So basically today all you're going to be doing is manipulating and working with the inverse trig functions. So if you want to get started on your assignment before we hit derivatives, here's what you're looking at. You have 1 through 8, 15 through 19, 21 through 24, and 37 through 40. Now this is the assignment for the entire section. So you probably won't be able to do everything.